Python. Functional programming. Functional programming is a programming paradigm in which it tries to bind each and everything in pure mathematical functions. It is a declarative type of programming style that focuses on what to solve rather than how to solve. Functional programming paradigm is based on lambda calculus. Instead of statements, functional programming make use of expressions. Unlike a statement which is executed to assign variables, evaluation of an expression produces a value. Functional programming is a declarative paradigm because it relies on expressions and declarations rather than statements. Unlike procedures that depend on local or global state, value outputs in functional programming depends only on the arguments passed to the function. Functional programming consists only of pure functions. In functional programming, control flow is expressed by combining function calls rather than by assigning values to variables. Now, an example is given where you have function calls to go with. Characteristics of function programming. Functional programming method focuses on results, not the process. Emphasis is on what to be computed. Data is immutable. Functional programming decomposes the problem into functions. It is built on the concept of mathematical functions, which uses conditional expressions and recursions to perform the calculation. It does not support iteration like loop statements and condition statements like if-else. Functional programming languages are designed on the concept of mathematical functions that use conditional expressions and recursions to perform computation. Functional programming supports higher order functions and lazy evaluation features. Functional programming languages don't support flow controls like loop statements and condition statements like if-else and switch statement. They directly use the functions and function calls. Concepts of functional programming: pure function, recursion, referential transparency. Functions are first class and can be higher order, immutability. Functional programming versus procedural programming. Now we have an example of functional programming and we have an example for procedural programming where you come across the difference. Pure functions. Pure functions always return the same result when given the same inputs. Consequently, they have no side effects. Properties of pure functions are: first, they always produce the same output for same arguments, irrespective of anything else. Secondly, they have no side effects, that is, they do modify any argument or global variables or output something. A simple example would be a function to receive a collection of numbers and expect it to increment each element of this collection. We receive the numbers collection, use map with the increment function to increment each other number and return a new list of incremented numbers. We have an example which defines inc of x returns x plus 1. So this function is used in map to go with to get the result. If a function relies on global variables or class members data, then it is not pure. And in such cases, the return value of that function is not entirely dependent on the list of arguments received as input and can also have side effects. A side effect is a change in the state of application that is viable outside the called function other than its return value. Recursion. In the functional programming paradigm, there is no for and while loop. Instead, functional programming languages rely on recursion for iteration. Recursion is implemented using recursive functions which repetitively call themselves until the case is reached. You have an example for that. This code performs recursion task as a loop by calling itself with a start and a new accumulator. Referential transparency. An expression is said to be referentially transparent if it can be replaced with its corresponding value without changing the program's behavior. As a result, evaluating the referential transparent function gives the same value for fixed arguments. If a function consistently yields the same result for the same input, it is referential transparent. Functional programmings don't have any assignment statements. For storing additional values in a program developed using functional programming, new variables must be defined. State of a variable in such a program is constant at any moment in time. Pure function plus immutable data is equal to referential integrity. Now we are implementing this using a square function. This pure function will always have the same output given the same input. So we have an example for this to go with. Immutability. In functional programming, you cannot modify a variable after it has been initialized. You can create new variables, and this helps to maintain the state throughout the running of a program. In imperative programming, this means take the current value of x and 1 and put the result back to x. In functional programming, however, x is equal to x plus 1 is illegal. That is because there are technically no variables in functional programming. Using immutable data structures, you can make single or multi-valued changes by copying the variables and calculating new values. Since functional programming does not depend on shared states, all data in functional mode must be immutable or incapable of changing. Functions are first class and can be higher order. A programming language is said to have first class functions when functions in that language are treated like any other variable. For example, in such a language, a function can be passed as an argument to other functions, can be returned by another function, and can be assigned as a value to a variable. Higher order functions are functions that take at least one first class function as parameter. You have an example for this. Higher order functions are map, reduce, filter. Now we have functional style for getting a sum of result. Pure functional way in Python using higher order functions to get the result. Map. Map can run the function on each item and insert the return values into the new collection. Have an example to go with. Reduce. Reduce is another higher order function for performing iterations. It takes functions and collection of items and then it returns the value of combining the items. Filter. Filter function expects a true or false value to determine if the element should or should not be included in the result collection. Basically, if the callback expression is true, the filter function will include the elements in the result function. Otherwise, it will not, which is given in the example. Functional programming non-strict evaluation. In programming language theory, lazy evaluation or call by need is an evaluation strategy which delays the evaluation of an expression until its value is needed and which also avoids repetitive evaluation. allows functions having variables that have not yet been computed. In Python programming, the logical expression operators and, or, and if then else are all non-strict. We sometimes call them short circuit operators because they don't need to evaluate all arguments to determine the resulting value. Now we have a command snippet to show this. When we execute the preceding command snippet, the left hand side of the operator is equivalent to false and the right hand side is not evaluated. So when the left hand side is equal to true, the right hand side is evaluated. Lambda expression in Python and other programming languages have their roots in lambda calculus. Lambda calculus can encode any computation. Functional languages get their origin in mathematical logic and lambda calculus. In Python, we use the lambda keyword to declare an anonymous function, which is why we refer to them as lambda functions. An anonymous function refers to a function declared with no name. When you want to pass a function as an argument to higher order functions, that is, functions that take other functions as their arguments. Characteristics of Python lambda functions. A lambda function can take any number of arguments, but they contain only a single expression. An expression is a piece of code executed by the lambda function which may or may not return any value. Lambda functions can be used to return function objects. Syntactically, lambda functions are restricted to only a single expression. We have an example for that. Closure. Basically, the method of binding data to a function without actually passing them as parameter is called closure. It is a function object that remembers values in enclosing scopes even if they are not present in memory. We have an example for that. Pure functions in Python. If a function uses an object from higher order scope or random variables, it communicates with files and so on, it might be impure. We have an example for this pure functions and impure functions here. Built-in higher order function. Map, filter, combining map and filter, list comprehension. Map. The map function allows us to apply a function to every element in an iterable object. Filter. The filter function tests every element in an iterable object with a function that returns either true or false, only keeping those which evaluates to true. Combining map and filter. As each function returns an iterator and they both accept iteratable objects, we can use them together for some really expressive data manipulations. List comprehension. A popular Python feature that appears prominently in functional programming languages is list comprehension. Like the map and filter function, list comprehension allows us to modify data in concise and expressive way. Anonymous functions. In Python, anonymous function is a function that is defined without a name. While normal functions are defined using the def keyword, in Python, anonymous functions are defined using lambda keyword. Characteristics of Python lambda function. A lambda function can take any number of arguments, but they contain a single expression. An expression is a piece of code executed by the lambda function which may or may not return the value. Lambda function can be used to return function objects. Syntactically, lambda functions are restricted to only a single expression. We have an example for that. When you want to pass an argument as pass a function as an argument to higher order function take other function as their arguments. Now you have examples with map with lambda with multiple iterators and maps to go with. Map function. Map function is a type of higher order function. This function takes another function as parameter along with a sequence of iterables and returns an output after applying to each iterable present in the sequence. We have an example to go with. Filter. Filter extracts each element in the sequence for which the function returns true. Filter first of all requires the function to return boolean values and then passes each element in the iterable through the functions, filtering away those that are false. We have the syntax for filter. The following points are not to be regarded during filter function. Unlike map, only one iterable is required. The function argument is required to return a boolean type. It does not filter, simply returns the iterable passed to it. Also, as only one iterable is required, it is implicit that function must only take one argument. Filter passes each element in the iterable through function and return only the ones that evaluate to true. It is right, that is the name a filter. You have an example for it. Now these are certain examples in Python to go with. Reduce. Reduce combines the elements of the sequence together using a binary function. In addition to the function and the list, it also takes an initial value that initializes the reduction and that ends up being the return value if the list is empty. The reduce function will transform a given list into a single value by applying a given function continuously to all the elements. It basically keeps operating on pair of elements until there are no elements left. Reduce applies a function of two arguments cumulatively to the element of an iterable, optionally starting with an initial argument. We have the syntax of reduce and an example of it. Map, filter and reduce function. You have map, filter and reduce using lambda to go with. Next, we use map to print the square of each numbers rounded off to 2 decimal places. We use filters to print only the names that are less than or equal to 7 letters. Use reduce to print the product of these numbers that has been specified. We have the example to print the sum of even numbers from the user input. These are certain examples that you come across to print the square and the quad. Functional versus procedural. Now when you go for this functional paradigm and procedural paradigm, you have certain points to compare with. The first one is treats computation as the evaluation of mathematical function, avoids state and mutable data. In procedural, derived from structural programming based on the concept of modular programming or the procedural call. Next, main triads are lambda, calculus, compositionality, formula, recursion, referential transparency. When you come for procedural languages, main triads are local variables, sequence, selection, iteration and modularization. In functional programming, it focuses on expressions. Procedural programming focuses on statements. Functional programming is often recursive, always returns the same output for a given input. Procedural programming, the output of a routine does not always have a direct correlation with the input. In functional programming, order of evaluation is usually undefined. In procedural, everything is done in specific order. In functional, it is stateless. No operation can have side effects. In procedural, execution of a routine may have side effects. In functional, good fit for parallel execution tends to emphasize a divide and conquer approach. Tends to emphasize implementing solutions in a linear fashion. Functional versus object oriented. When you go for this functional versus object oriented, functional programming uses immutable data. Object oriented programming uses mutable data. Functional programming follows declarative programming based model. Object oriented follows imperative programming model. Functional programming, what it is focused on is what you are doing in the program. Object oriented programming, how you are doing your programming. Functional programming supports parallel programming. Object oriented does not support parallel programming. Functional programming, functions have no side effects. Object oriented paradigm method can produce many side effects. In functional programming, flow control is performed using functional calls and functional calls with recursion. In object oriented programming, flow control process is conducted using loops and conditional statements. In functional programming, execution order of statement is not very important. In object oriented programming, execution order of statement is important. Functional programming supports both abstraction over data and abstraction over behavior. In object oriented programming, it supports abstraction over data.